record. No. Share. Okay. Make sure. Hold on. Testing volume. Okay. Okay. So to turn a number from standard notation to scientific, we're going to place the decimal point so there's a non-zero digit to the left of the decimal. And again, this will make so much more sense once we do an example. Non-zero digit to the left. We're going to count the number of decimal places it moved, and this is going to be the power of 10. A very large number will result in a positive exponent. A very small number will result in a negative exponent. Yes. Power. So our 4 words to fill in: left, power, positive, negative. Now, once we do some examples, you may never have to read that again, but if you need to, say the end of the unit, when we're doing our unit test, if you need to look back, I like that it's written in words too. So let's do some examples. Let's start with a fairly small number, 41,000. When it comes to scientific notation, this would be considered a fairly small value when we think about the types of numbers we saw. Okay, so first step is to place a decimal point in this number to create a value between 1 and 10. So here's what I mean. Take this, post it. 41,000. So the decimal is currently here, right? Where, if I were to pick it up and put it somewhere else, where is the only spot I can put it to create a number between 1 and 10? There's only one place. Sean? After the 4, right? I would create 4.1 with a bunch of zeros. 3. Everybody agree? Okay, so that's what we're going to do. We're going to place our new decimal between the 4 and the 1. And we're going to count those movements from the original decimal to its new location. 1, 2, 3, 4 spaces. So our number in scientific notation is 4.1 times 10 to the 4th. Because remember, 10 to the 4th is 10,000, right? Times 4.1, that would get me back to 41,000, right? 10 to the 4th is a number, but to write it quicker, scientific notation. Okay. All right, let's do another one. Number 2. Let's do a really small number. Let's see if I can say this one. Okay, so we're going to write 31 millionth. That's a decimal with 4 zeros and then 31. So again, I ask you, where does the decimal need to go to create a number between 1 and 10? If I picked it up and chucked it somewhere else, there's only one place it can go. Where would that be? Yeah. After the 3, right? I'm going to move it here. 3.1 is my number between 1 and 10. Times 10 to the, now let's count. 1, 2, 3, 4, 5 spaces. And it's a small number, so I want you to put a negative power. 10 to the negative 5th. Because remember, 10 to the negative fifth is really 1 over like 100,000 or something, right? Times by the 3.1, that would get us back to this decimal. Yes. Say it again, 10 to the 4th. Great question, because it's not necessarily the zeros that make the exponent, it's the number of place values we have to move over. So there were 3 zeros, but that extra 1, that's why we have 4 spaces of movement. So this one, see how there are 4 zeros, but that 1 extra movement, that's where we get our 5. Yes. Great question. So the negative exponent, here, I want to come over here. A small number is our negative exponent, and a large number is the positive exponent. Small negative, large positive. Okay, so let's talk about turning a number from scientific to standard. You're going to move the decimal point to the right for positive exponents. And you're going to move the decimal point to the left for negative exponents. Now, I don't want you to have to memorize directions. Like, I don't want you to say positive means right, negative means left. I want you to think about it differently. So here's how I would like you to think about it. Number 3. Let's take 3.1. Nope, sorry, we just did 3.1. I'm trying to switch it up. 3.6 times 10 to the negative fifth. So again, I don't want you to say, okay, it's negative, I move left. Like, I don't want you to think about it that way. If it's a negative exponent, it's a very small number, right? It's teeny, teeny, tiny. So when I think about, if I were to move the decimal left, that would make a small number. If I move it to the right, that would make a bigger number, right? Even if I move it 1 space, it becomes a 36, it's bigger. I don't want it to be bigger. So I know I have to move it to the left because that is the only way to make it smaller. I don't want you to have to memorize the directions. Just by knowing it gets smaller, we should know to move it to the left. So here's how I like to do it. I'm going to rewrite 3.6 down here. And then I'm going to move that decimal point 5 spaces to the left. 1, 2, 3, 4, 5. There's my new decimal point. And I'm going to fill in zeros. And then I'm going to rewrite this number so it looks pretty. You should have 4 zeros. And then a 36. Again, left because it needs to get small. If I move that 5 spaces to the right, what would that become? 360,000? That's a big number. That's not what I want. I want the small one. Number 4. $2.35 times 10 to the 6th. So again, I kind of ask myself, is this a large or small value? Well, it's a positive exponent, so I know it's a large value. And if I think about what direction to move my decimal, the only place I can move it is to the right, or it wouldn't get bigger, right? So I'm going to take my 2.35 and move it over 6 spaces from its spot. 1, 2, 3, 4, 5. and fill in my zeros. Oops, sorry, did I do only 5? 1, 2, one more. 6. And put in some zeros. 2, 3, 5 with 1, 2, 3, 4 zeros and put commas. Now, this may be something silly to you, but I am requiring that you put commas in those extremely large values. No joke, I will take off half a point from your future tests or quizzes without commas. That is a way for me to quickly identify if you have the right value or not without counting all these zeros. Guys, we're going to have some with like 15 zeros. So just help me out, put the commas, you'll get used to it over time. Yeah. I'm sorry, I called on Lucas. Yes. Right? Yeah. Look at the mass of proton. Yeah. Yeah, it's not a good time. Kyle, did you have a question? Because remember, I've already said this, the exponent does not signify the number of zeros. It signifies the number of times we have to move the decimal point. So there are 2 non-zero values in our number. That accounts for 2 of the exponents, right? And that's why there are 4 zeros after to get to our 6 total spaces, okay? Now, unfortunately, for the first couple of examples, I only gave you like a 2-digit decimal, if you will, right? So remember, they can be any number between 1 and 10. Doesn't always have to. Most of the time, you'll see it only to the 10th place. But okay, let me stop recording here.